Hello, my name is Balázs Benyó from the Budapest University of Technology and Economics, and I will introduce Biomedical Informatics Research Group research activity. Due to the increasing cost of medical services, one of the largest challenges of the healthcare system is to provide and develop cost-effective and effective medical services. Model-based medical therapy is one of the ways how we can implement such services, as I told, on a cost-effective way. Model-based approach in medicine is quite straightforward. As we have a medical problem, we can identify the related physiological processes. We can create their models. However, we have to choose those models that could be identified on the bedside, as we won't like to provide treatment directly on the bedside. As we do have these mathematical models, we have to validate them in order to assess their accuracy. And these validated models could be used in medical diagnostics, prediction of patient states, future states, and treatment optimization. Generalizing this approach, we can create the digital twin, which is actually a use borrowed from the field of Industry 4.0. We do the same thing. We do have the patient, we have to collect as much measurement as we can do, so we measure their physiological signals. We will interpret those signals by using our models, and we will extract those features which could be used for supporting the clinical decisions. Let me give an example by the model-based glycemic treatment. In this case, the physiological process is the metabolic system of the human body. We can use or we can develop a compartment model to describe such a system. And for describing this system, we will use a differential equation, what we can implement in even a tablet application, what we did in the STAR application. The STAR treatment or STAR medical protocol actually aims that the glycemic treatment of the patients under intensive care. We measure the blood glucose level of those patients and enter those data into the tablet computer, which will optimize the treatment, select the best treatment option for the patient, and will give advices for the doctors or nurses. In the STAR application, we identify the patient state by identifying the insulin sensitivity parameter of the patient. We actually predict the future state of the patient and run in-Silico simulations in order to compare the outcomes of the different alternative treatments. In such a large-scale project couldn't be implemented by a single research group. So we started this work in the framework of the e-time project, where we created an international framework with medical service providers and research organizations. Currently, we're continuing this research work in the DCPM project, where we actually targeted all the three treatment fields of intensive care: the cardiovascular treatment, the glycemic control, and the mechanical ventilation. Our vision actually to have those models, develop those models, and actually turn those models and methods into real clinical applications, as we did in the past with the STAR application. As I told, this work is done in the large-scale collaboration, international collaboration. Thank you very much for your attention. Please send your emails if you have any further questions.